Hello, everyone. Welcome. Welcome to our February webinar in March. I'll give just a few more seconds for people to come in, and then we'll get started. Thank you, everyone, for coming. All right. Well, it is the top of the hour, so we will get started. Thank you so much, everyone, for joining us today. Welcome to the Monarch Conservation Webinar Series. Today's webinar is Designing Monarch Overwintering Habitat in California, Advances in Measuring Canopy Structure and Modeling Microclimate. Our presenter today is Stuart B. Weiss, Chief Scientist at Creekside Science. My name is Jenna Tots, Senior Education Manager, and I'm joined by my coworker on the back end, Alyssa Taylor, Online Education Manager. We begin today by honoring the land on which we live and work. The offices of the Monarch Joint Venture are located in St. Paul and Belle Plaine, Minnesota, and we acknowledge that this land is the traditional homelands of the Dakota people, specifically the Mdewakanton Dakota, who have lived here for generations and continue to live here today. We recognize the enduring presence and contributions of Dakota and Ojibwe nations across Minnesota. We invite you to use Native Land Digital, native-land.ca, an Indigenous-led nonprofit organization, to see a digital map of Indigenous territories, languages, and treaties in your area. We want to thank all of our sponsors, including the Monarch level sponsor Bayer, for their support of MJV's virtual education, including this webinar series. If you or your company are interested in sponsoring this year or next, please email learn@monarchjointventure.org. Before we get started with our wonderful presentation today, we just have a few community guidelines, helpful hints in order to make your webinar extra special. If you are joining us today but weren't able to pre-register for the webinar, we want to be sure we are able to count you for attendance. Alyssa will add the link so you can get signed up. If you've signed up already, no need to sign up again one time, and you get the emails throughout the entire year. This webinar will be recorded and posted to the Monarch Joint Venture webinar website by Friday of this week. We have the entire Monarch Conservation webinar archive on that site. It is over 11 years of content. It is all free to watch. There is some really wonderful content if you haven't checked that out before. During the webinar, please put your questions in the Q&A box. You'll find that at the bottom of your Zoom screen. If you don't see it, you can click on the More button. It's a circle with 3 dots, and you'll see the Q&A right there. Please don't use the chat for questions. It's just easier to keep us organized. You can also upvote different questions that you see in the Q&A if it's something that you're really interested in learning about. Also, we invite you to use the reactions during the presentation. That can also be found on the bottom of your Zoom screen. You are welcome to practice real quick. Again, if you don't see it, click on the More button and choose reactions. There we go. Sometimes in a webinar, it's hard to express. So please feel free to use those. Stu can see those when he's presenting. We want to remind you there are also translated captions on this Zoom call. If you'd like to add captions in a language other than English, click on the arrow by captions, the little caret, and then be sure your translation button is on the your chosen caption language. And finally, all of our webinar speakers represent their own viewpoints, which are not necessarily those of the MJV. And without further ado, I'll introduce our presenter. Stu has wide-ranging research experience in conservation and population biology, microclimate characterization, and statistical analysis. He worked for over 15 years at the Center for Conservation Biology at Stanford University, has authored more than 25 scientific publications, and has served as principal investigator for more than 50 grants and contracts with the U.S. Fish and Wildlife Service, California Energy Commission, Silicon Valley Land Conservancy, and more. And with that, I will stop sharing my screen and pass it over to Sue.
And I'll share mine.
Great.
Email. Here we go.
Looks
Okay.
good.
Yeah, thanks. Okay, so we're going to California today, and I'm going to talk about literally designing overwintering habitat. as opposed to leaving it to chance, and some of the techniques that we use. And yeah, so I'm going to be presenting like some problems that we solved using these techniques. So we're all familiar with the Monarch migration. All of you east of the Rockies, your monarchs head to Mexico, which they go to these high elevation conifer forests, and there are, millions, tens of millions, or even hundreds of millions of monarchs in the colonies down there. But I'm not going to talk about that today. We're going to look at the Western migration, which west of the Rockies, the butterflies in late summer go into reproductive diapause, become migratory, and head to the beach in California where they overwinter. So the ancestral condition of this migration, to the best we know, relied on a relatively few stands of native pines that are right next to the oceans. This is Monterey pines at Point Lobos State Reserve, and the monarchs still do overwinter in some of these stands, but they've been vastly impacted by development. So the monarchs, being incredibly opportunistic, now largely, not exclusively, overwinter in groves of non-native eucalyptus trees. These trees were planted up and down the coast for windbreaks, woodlots, and some rather misguided timber production uh, projects. And the monarchs, being incredibly opportunistic, just started checking them out and found them much to their liking, so they've become overwintering sites. The distribution of overwintering sites in California goes from northern part of Sonoma County all the way down to, get my laser pointer here. So Sonoma County up here, all the way down into Baja. And the heart of the range is from the Bay Area down into Santa Barbara and Ventura County. The orange dots here are the top 50 sites as determined by the Xerxes Society. We can compare this to that's the ancestral condition of Monterey pine grove. So monarchs have vastly uh, increased their distribution along the California coast. Just showing a snapshot of 4 different sites. So here at Pismo North Campground, consistently one of the largest sites in California, there's just a few acres of blue gum eucalyptus and some other trees right adjacent to Highway 1 and sandwiched between the campground and the highway and a railroad line and suburban development. Down in Elwood Mesa and Goleta, another one of the historically major sites in California, there's about 90 acres of eucalyptus forest, primarily blue gum, but some other species. And the monarchs have found places within the forest that count as separate overwintering sites. But of course, they interact with each other a lot. Here on Harbor Boulevard in Ventura, it's basically just a double row of eucalyptus planted as a windbreak. The ocean is in that direction. And the windbreak is protecting these agricultural fields. And then there's Highway 101 going by. And then Pacific Grove, Monarch Grove Sanctuary, where we'll be taking a much deeper dive, is a small property and adjacent trees in the middle of suburban Pacific Grove. So a lot of these sites are quite urban, and some of them are quite rural, but there are hundreds of them. So the Western monarch population is frankly in pretty bad shape. So there were estimates back in the 1980s of, millions or even tens of millions of monarchs. flying to California from across the area west of the Rocky Mountains. And then, some big declines. And then when the Western Monarch count, the WMC, which is in this inset here, started, there were over 1 million monarchs counted in California in about 100 sites. So over time, we see that the numbers went down into the low hundreds of thousands with a few alarming dips here. And then let me just go to the finer scale. Uh, so here we are. Then we see some big declines in 2018, and 2020 was the year the bottom dropped out. But then we had a miraculous recovery, which I can talk about later, into the hundreds of thousands, similar to what it was prior to this big dip. But then in the past 2 years, it's been down around 10,000. Now, being a population biologist, I kind of insist that we look at this on a logarithmic scale. Both you can see the fluctuations a lot better, but it's also the mathematically correct way to look at populations, because it's a multiplicative process, not an additive process. So, here from 1997 through to about 2017, these are what we might consider to be sort of normal population fluctuations around what's admittedly a much lower baseline. Then we had a big decline in 2018, stayed the same in 2019. 2020 was estimated there were like 2,000 monarchs in the overwintering sites. But then in 2021, 22, and 23, we had a recovery. And then 2024 and 2025. There are numerous reasons for this, but climate is a really important component of it. But I don't have time to go into that now. So I'm going to, kind of make the pitch that overwintering monarch habitat in California is actually some pretty good news here that I hope you'll uh, indulge me in. So again, we had the ancestral condition, which were native Monterey pines in 3 areas in coastal California. Now, the current is hundreds of stands of non-native eucalyptus and other species across a much broader geographic range. So the dynamics of the monarch migration to the overwintering grounds is the diapausing migratory generation flies to the ocean. They start finding groves of trees to roost in during the night. And what they manage to find are these sunny, wind-sheltered forest nooks in various stands. And I call this crowdsourcing the microclimate because it's kind of the net result of every monarch making a decision about whether they like being where they are right now so they don't move, versus leaving because it's too hot, it's too cold, there's too much sunlight, there's not enough sunlight, too windy, too humid. They leave. And then as they're searching for new sites, they cue in on the presence of other monarchs as the indicator that it's a good place to be a monarch. And this works as we look at how they sort themselves out among groves. And it also works as they shift their micro distributions within the groves. So I've worked in more than 50 monarch sites in California since 1990. I have had a lot of examples I could pull for this talk. I'm going to look at 4 of them that illustrate various problem solving. And, I've sort of seen it all in terms of monarch behavior and site dynamics. So we need to realize that these sites have developed unintentionally over the decades. And now we really need to bring them under long-term management. We can't leave it to chance and accident anymore on maintaining those wind-sheltered sunny nooks. So again, we need to maintain the microclimate. We need to address tree fall and fire hazards in dynamic forests. So these aren't museum pieces. Really important to keep that in mind. So what I'm going to show you is how we assess canopy structure in microclimate using hemispherical photography or hemiphotos, and then some relatively recent work over the past 7 years using LiDAR and modeling wind uh, above and within the Monarch sites. The key management actions are plant new trees and thin stands for various reasons. And what I won't be able to get into is the navigating the institutional landscape. These are the kind of stories that are good over beer and wine after a talk, because it's more vexing than the actual microclimate questions. And every site has a unique mix of these. So the methods. First method I got into was hemispherical photography, which is a very well-developed technique of characterizing forest canopies. Here I am up to my neck in poison oak at a monarch site. I'm dressed in overalls to protect myself. And then I have in my hand a fisheye camera rig. So it's a camera body attached to an 8 millimeter fisheye lens. It gives a 180-degree field of view. It's mounted on a gimbal, so it's always level. And then I use the compass to orient it to north. And I come up with a photograph that looks like this. So the horizon is out here at the boundary. The zenith directly overhead is in the middle of the photo. And I have software called HemiView that superimposes on a grid. And in this case, it's 8 different azimuth or directional wedges, and then 5-degree increments of zenith angle, the vertical angle. And what the program does is you classify the pixels into sky versus obstruction, and it just counts up the pixels and the percentage within each of these sectors, and then you can start deriving how open it is in different directions. So when we do that, the first thing we see is you can see 23% of the sky from this particular photograph. But then when we look directionally, which corresponds sort of to wind directions, you can see 43% of the sky to the north, 36, 35. But then we have much more closed canopy over here with 11%, and then intermediate with 16, 15, and 17%. I can snap dozens of photos over the course of a session and map out the exposure. So I'm really looking for what I call bad holes, bad canopy gaps that let in the wind. And then we can also do the same thing with solar radiation. This is a rather closed canopy site, and we superimpose the path of the sun, which is astronomically determined. And we can count up the number of pixels in each of these half-hour segments for different months and turn that into a measure of solar radiation under clear skies or cloudy skies. So we're able to quantify light and wind. Again, this is from ground level, so there's some caveats here, but that's basically what we do. So here we have some good holes that let in sunlight, and this tends to, in parts of the year, it's going to be dappled light coming through the small canopy gaps, plus some short periods of direct light. But you could imagine with a large gap, you can get hours of full direct sun. So I developed this technique back in 1991, this article in Conservation Biology, and I was really proud we had the cover shot of Conservation Biology. And this was the result from a series of sites around Santa Barbara. So we have the permanent sites. This is where monarchs hang out all year, are in the black, and you can see they're in a very narrow range of what we call indirect site factor, which is essentially sky exposure. So somewhere around 20% of the sky seems to be really optimal for them. Then we have transient sites where the monarchs would be, but then they'd leave, and that occupies a broader range. And then also they don't like too much direct sun, but they also don't like it really dark. And then the unoccupied sites, which historically had been occupied by monarchs, but because the canopy opened up too much or closed in too much, they were no longer there. So they're looking for a pretty narrow range of canopy conditions. So now we're going to see how that plays out in doing site management. So we're going to go to Monarch Grove Sanctuary in Pacific Grove. This is one of the most famous California sites. Pacific Grove is Butterfly Town, USA, and they managed to conserve their very last decent monarch site in the early 1990s. And there's about 2.5 acres of public land, but there are private parcels around that are providing important wind shelter. So it gets complicated. Now, the mid-season counts, or the formerly Thanksgiving counts, are almost 50,000 monarchs in 1997, and then we've had fluctuations into the tens of thousands, 15,000 recently, but then like the California population as a whole, it really collapsed. There were 0 monarchs here in 2020, and in the last couple of years is just low hundreds at best. But again, that's tracking the overall California population. So back in 1997, I was contracted by the city to do an assessment and come up with a site plan. I'm showing you the key take home from that report. So this is a hemiphoto taken from that spot right there. And what we can see is that it's very, very open to the northwest, and that's a major prevailing wind direction. So this is the major vulnerability of this site. And that was driven by these essentially dying Monterey pines. They had reached the end of their relatively short life, about up to a century. And then also the grove was infested with pitch canker, which is an introduced disease that really can take out weakened pines. So the diagnosis here was that this gap to the north west was just letting in too much wind. And it led to this dynamic that we would see where the monarchs would be right along this southern edge here primarily. And they'd be on the sunny south edge. But then we get a storm with southerly winds. They'd move over to the north side of that row of eucalyptus trees. But then when the wind would naturally shift back to the northwest, they would have to boogie back over to the south side. So it was kind of this constant back and forth, adjusting to the wind and the light. So our diagnosis was that we had to get a shelter belt built in there. And we used blue gum eucalyptus, planted them in 1999. They were rather large 30-gallon trees, so we gave them a good start. And it was a double row offset to create maximal wind shelter. We also planted pines and cypress, but we decided on the blue gums because that was the sure bet. You know, pines wouldn't necessarily live to maturity. Cypress was relatively slow growing, but having a mixed shelter belt was really important. So then what happened? Well, actually, here's a view looking down from the fisheye from a bucket truck, because I did have the opportunity to get up higher in the canopy. So we can see here's the eucalyptus that we planted. Here's one right here. Here's one right here. And that arc kind of extends back around that way, and that way is northwest. Here's the main row of eucalyptus that is a real anchor of the site. And then in the interior, we have a series of pines and cypress. These are the overstory canopy pines that are dying off. And then some recruiting trees. So what we had hoped was that the monarchs would be able to move into the middle of the grove, um, protected by the new shelter belt. And indeed, that's what happened in 2013. The monarchs finally found that the wind conditions in the interior here were suitable for them to stay there for the majority of the season. So this took 13 years for the eucalyptus trees to grow up to be about 50, 60, even 70 feet tall. They grow really fast, and provide that key wind shelter. And then here's another photo of monarchs clustering in the interior. And if you look closely, there's actually a few blue tags in here, which I'm sure somebody who was monitoring got got those tag numbers. So that, that took a while, but and the site is still under management. So just to show you a little more dynamic, so this is in 2022, 23, which was a really, really stormy year. So we have these different zones. We have the south edge, the south interior, the interior, and the north interior, and then here by the driveway. And here's the monarch distribution in total numbers. So in the beginning of the season, they were on the south edge in blue here. Then we got a bit of a windstorm here. So this is the maximum hourly wind at the Monterey airport showing regional wind. So we had a wind event. Then they moved to the south interior and they stayed there for a while and numbers peaked out at close to 16,000. But then we got later in the season, we had a few more strong wind events. They moved into the interior, the darker green here. And then after this period of storm after storm, um, in January, they ended up way hunkered down here in the north interior. And the exact spots where they go to tend to be a little more sunlight than the surrounding areas. So they're responding both to the wind, but also choosing microsites that are really dependent on the sunlight. And then at the end of the season, they moved into the driveway because this is the time of year when they want to be active. They break diapause, and the driveway area gets a lot of morning sun because it's facing towards the east. Okay, now we're going to go down to beautiful Big Sur. So this is Andrew Malera State Park. This is a site that started to be monitored around 2001, and that's when I did my first study there. And much smaller numbers than Pacific Grove. And then, boy, there were no monarchs there from 2018 through 2022. So again, here's the aerial view of it. It's a small patch of eucalyptus. Here it is from the ground. There's a settler's cabin in here. And some of these trees were planted in the 1850s and are just huge. They're the oldest eucalyptus along the coast, along the central coast. So when we go into the grove, here's a photo of one of the cluster sites. So monarchs would cluster immediately above here in 2001. You can see that it gets a lot of sunlight, nice open gap here. But then there's a gap that really lets in the wind. What we found was described to me is that they'd be here until we'd get a storm, and then because of the wind exposure, they would duck over to the other side of the trees to get out of the wind. But then the other side of the trees is exposed to the northwest wind, kind of that same dynamic that we had in Pacific Grove where they're moving around. Well, then it went back in 2020 and it looked a lot different. So this tree and this tree, that's the same tree you might recognize. The site, there's just a huge amount of densification, is that new trees came in and really blocked off both the wind, but also importantly, the sunlight coming in from the south. So when I look at the amount of solar radiation that we had here in 2001, this site was receiving a lot of solar radiation in the winter, um, sunny. But then in 2020, when I reran the solar exposure, it was really, really dark. And monarchs do not like to cluster in really dark sites because they need some light, especially dappled light, so they can thermoregulate. So this was a loss of sunlight, and the monarchs no longer would cluster in this area. So what's the way to let in more sunlight? Well, we thinned some of the encroaching trees. So we selected about 50 trees that were less than 10-inch DBH. Here are the areas where the monarchs like to cluster. And Jeff Frey of California State Parks waded through the poison oak and marked these trees, and they were cut down and stump treated in 2022. And that opened up a much more cathedral-like uh, structure in the forest. And then in 2023, when the monarchs had recovered, there's about 1,000 monarchs that showed up in the opened area now. Whether that was specifically because of the way we opened up the forest, I'm not going to claim that as a definitive uh, thing, but it's encouraging. So forests can be too dense, so we can open them up. Now, the latest technology, I started using this in 2019 and 2020, is called LiDAR. So LiDAR is laser scanning from an airplane or a drone, and you get pretty high density images of the forest ranging from 5 to 250 points per square meter, and you get multiple reflections. So you get a 3D structure of the forest, which you can then examine and then also do analytics on. So I'm going to show you a couple of other couple of sites where we used the LiDAR to do wind modeling. And then here's what a hemiphoto looks like from down here in that gap. This was a site where the blue gum eucalyptus, this is down near Santa Barbara at Elwood Mesa, where there was a massive mortality in the forest because of a 1 in 1,000+ year drought in the mid 2010s. So you can see all these dead trees, and the forest really opened up there. But now we're going to go up to another kind of urban site. This is the Gill Tract Community Farm in Albany. It's owned by the University of California, Berkeley. And this little grove here turned out to be a really important site in the nadir of the monarch population. So of the 2,000 monarchs that were counted in California that year, 60 of them were counted at the Gill Tract, and it was actually one of the larger sites that year. And then in recent years, the pop numbers have gone way up into the low hundreds. So right now, when this photo was taken, there was a big open field here. And the University of California, Berkeley wanted to put in student housing, graduate student housing, 6-story apartments. And the question was, well, what kind of impact would that have on the Monarch site here? So we used a program called WindNinja, which I love that name. I have to get dressed up in my special black robes to use it. And we wanted to model the wind effects of a 6-story graduate student apartment complex. So here is the before the apartment complex went in, the monarchs were using the most interior site in 2020 to 2023. And this was a bunch of drought-stressed redwoods. They were planted well outside their native range. native climate envelope, and they hadn't been managed, so they were really drought stressed. But they used this most interior site, which to me generally indicates they're trying to get away from the wind. So we were able to model the wind over the outer canopy surface. So you can see the hillshade here showing where the canopy surface is, and the red is the more wind exposed, um, and the blue are the more wind sheltered. So we can see that the outer canopy at this site is sort of in the middle. So it's better wind sheltered than the edges, but not as wind sheltered as in the lee of the trees. So then we digitally put in the building. This was before it was built. So now you can see the structure of the building. I can see there's a lot of wind right on the roofs of the building and this big wind shadow back behind it. And if you look closely, you'll see the wind shadow extends to the edge of the grove. So I did a difference between them, and this was a 10 meter per second southwest wind. So, you could see that, yeah, here's the wind shadow where it really reduced in the lee of the building, but the effect uh, dropped it by several meters per second all the way to the forest edge here and actually at the cluster site. So it's a good thing. A six-story building is a better windbreak than a big open field. So here's what the student housing looks like. There are now hundreds of happy graduate students living there, helping to solve a really critical housing shortage in Berkeley, Albany area. And now we see monarchs are much more likely to be roosting in clusters along this edge because it's now wind sheltered. So here's a photograph of them hanging out there. So the other, besides having a better wind shelter at the site, we were able to get the site under management. So we could irrigate the drought-stressed redwoods and then plant more trees so that we could deepen the site and deal with the wind exposure from the northerly directions, which was still kind of a problem. So this is a tree that was planted in May 2023. It was about this height. And then over the 18 months, it pretty much doubled in height and they're still growing like gangbusters. So now there's actually a management process at this site, which is really key. So here's what it looks like after. Here's the student housing, and then here's the grove. And if you look really, really closely, you can see the new trees that were planted, which will be a lot. You're going to fill in this area and create a lot more depth. Okay, now our last site, we're going to go to Moran Lake, which is in Santa Cruz. This is a pretty major, one of the big three sites in Santa Cruz. It's had in the like mid thousands of monarchs in good years since 1997, but it's also like all sites following the overall population. Notice how urban this is. It's completely surrounded by houses. So we took an existing LiDAR flight that was county-wide, about 13 points per square meter, and came up with this 3D model looking from above. The dynamics of the monarchs here, we have this area called the yard, which is a sanitation facility, corporation yard, big opening that's completely surrounded by a rectangle of eucalyptus. And the monarchs here tend to do that dance back and forth where early in the season they'll be over here, but then it's nice and sunny, east exposure, and but then it gets too exposed to wind. So they duck back into here. But then sometimes when the wind starts coming out from the northeast, there's some gaps in the forest. They head back over here. So we get this dance back and forth. So what we were really interested in doing was seeing how important and how high this row of trees needed to be to provide the wind shelter for the Monarch site over here, because southwest winds coming in this direction are a really, really important uh, part of the climate in this part of Santa Cruz. So we used a program called Eddy 3D, which allows us to model wind within forests. It's computational fluid dynamics. And this was developed by Kyle Nesson and Corbin Matley with Althouse and Mead consultants, who were my partners on this particular project. So here's the fundamental question. We have these eucalyptus trees towering over all these houses. Eucalyptus trees have been falling down onto people's houses in this area. Unmanaged forest, really lousy rooting. So the question is, how tall does this windbreak need to be to provide wind shelter for the monarchs that are like way back across the corporation yard? So we used the program WindNinja, no, I'm sorry, Eddy 3D, and this is the a profile taking across the corporation yard. These are various buildings. Here's the approximate place of the eucalyptus grove. So we blew a hypothetical 10 meter per second wind across here. And then you can see how there's a wind shadow effect as we go downwind. And then here's the cluster zone over here. So you can see it's mainly yellow, which is less than 7.5 miles per hour, or blue, which is less than 5 miles per hour. So this is the current condition. So just to be really extreme and set a benchmark, we just completely removed it. In the computer, we didn't cut any trees, and we can see how the cluster zone, because there are trees in this area, it's not completely exposed to the full wind, but wind speeds go up considerably, and it's a much less suitable site for the monarchs if we did complete removal. So then we shaved off 10 meters at 10 feet at a time from the grove and reran the model. So here's the 80-foot model. And we can see that the cluster zone is now back into a lot of blue. And we're still getting substantial wind shelter across the corporation yard, like 400 feet downwind from the shelter belt. So in order to like really quantify this, we had a few hundred points within the cluster zone that we extracted out what the wind speeds were. And here I'm classifying them. So here's the height. So here's the original height. And then 10 feet off all the way down to 0. And these are the different percentiles of wind speed within the grove. So in the initial, this is the, get you out of the way so I can actually read. Uh, the 10th percentile, so 10% had less than 1 meter per second. 25th percentile was between 1 and 2 meters per second. The 50th percentile was 2 meters per second. And then the 90th percentile was up at 4 meters per second. And that's where we think that monarchs start really being disturbed, but there are plenty of other places. Now, we didn't see much change. And then interestingly, at 100, it went down, and that's because of some wave dynamics in the wind. But then we start seeing that the wind speed, distribution of wind speeds go way up when we hit about 60, below 60 feet. So we decided that let's take a look at 80 feet. 80 feet would actually protect those houses from tree fall, but would also provide a lot of wind shelter down at the Monarch site. And then also it gave us about 20 feet of buffer. So like in good engineering, you want to build in a margin for error. So that's what the plan is to take those trees down to 80 feet, protect the houses, but maintain the wind shelter in the Monarch zone. So those are four of many, many problems I've dealt with over the decades. So just thinking big picture, conserving and managing the California overwintering sites is necessary for conserving the monarch, Western monarchs, but it's not sufficient because the real problems that are um, driving the population down have to do with pesticides, the availability of milkweeds, climate in the breeding range, and then also warm winters that lead to early emigration back into winter conditions, like we saw this year and back in 2018 and 2020. Now we need to remember monarchs opportunistically and dynamically use the available overwintering habitats. And we need to conserve and manage, really important manage, a series of overwintering sites up and down the coast. So the more sites we have under management, the more we can maintain that sunny wind sheltered nook or nooks that they like and give them lots of options. The scientific tools I've just shown you can guide the provision of suitable microclimates and complex and dynamic forests. And it's a combination of all microclimate factors, light and wind and humidity are important. There's some very recent work, which I'm sure you're going to hear about, showing that our original wind thresholds were like really conservative, and monarchs have a lot more tolerance for wind than we thought, but they still do react to wind. But sunlight is really important. Within these urban zones and even in the more rural zones, safety and fire need to be addressed. We can't have trees crashing down and on houses and on people. I lived through one of those tree falls in Pacific Grove in 2005, and I never want to go through that again. That's a story, again, that's like, take a while to tell. And lastly, the social and institutional aspects of this kind of work are more vexing than the actual environmental biophysics and analysis of forest structure. People aren't very patient, but the fact it takes 15 to 20 years for trees to grow up tall enough to function as windbreaks, that just comes with it. People don't like to take trees out. But sometimes we need to for safety reasons, and then also in some cases to let more light into the habitat. So I hope I've given you a bit of a flavor, and we want to keep the monarchs happy in their sunny wind sheltered nooks and turn this monarch habitat into more like engineering and design as opposed to simply letting things developed by accident and get more and more sites under scientific management. So thank you. I'll leave this slide up so we can
Beautiful.
all smile along with the monarchs here.
Absolutely. Thank you so much, Stu. We really appreciate your expertise. And before the webinar was started, we were talking with Stu, and I was just sharing, this is new information to me. I had not heard of Stu's research before, and just incredibly fascinating. Personally, I really love the story of the graduate housing being built. And you think right away, like, not a good thing. Like, we don't want that. That's going to be detrimental. Clearly, in this situation definitely helped. So able to look at this situation from an engineering perspective. Not often we do that when we're talking about butterflies. So thank you again for sharing your expertise. We do have some questions that we're going to ask Stu here. If we don't get through them all, we'll be sure to ask Stu via email, and then we will follow up by Friday with answers and other resources. I'm just going to start with the last site that we were at. Have those trees been cut back to 80 feet yet? Or has that not happened yet?
No, not yet. Not yet. It's they're planned to be prob might be this summer. One of the general rules in California is you don't do major tree work during the overwintering season. So that's just ended largely. So I think they're going to start doing it. Now, there's definitely some issues when you top a eucalyptus tree. You get this lollipop type structure on top and a lot of poorly attached branches. So we're setting ourselves up for like perpetual maintenance once the height is reduced. But also we'll tend to see that the holes that were in the grove are going to fill in, because one of the great advantages of eucalyptus is they do epicormic sprouting. So they'll start sprouting along their trunks and along branches with as more light becomes available. So they're kind of self-sealing in that regard. And pines and eucalyptus and pines and cypress don't do that.
All right, so something to check out this summer if those get our Santa Cruz folks will have to let us know when that happens.
Mhm.
I know you mentioned forest fires and thinking about that. Are eucalyptus trees the long-term solution given their flammability rating? What are other options?
Okay. I co-authored a paper in the California Department of Fish and Game Journal. That basically made the case if we need to manage eucalyptus, um, if we want to have monarchs. Both pines are actually as flammable or as eucalyptus, or even more so. So it's more a matter of the forest structure that allows for fire to carry into the canopy. Um, we had a small fire at Pacific Grove in, fortunately, the end of a very wet March 2023. So they got on it really fast, but that scares the hell out of me. Um, so dealing with ground fuels and ladder fuels is really, really important. So that first 6 to 10 feet above the ground, which in a lot of cases is not the real critical windbreak for the monarchs. It's really important to, do very careful fuels management in these sites. Because the last thing we want is the whole site to burn up, because that doesn't do the monarchs any good. So, yeah, fire is a real issue, again, because what we need for the monarchs is almost ground to top canopy wind shelter along the edges. And that really freaks out the fire people, as you might imagine. So there's a lot of negotiation that has to go on.
Interesting. Thank you. Here's a question from Natalie Johnston. She's at Pacific Grove Museum of Natural History. She's been wondering all monarch season this year at Pacific Grove Sanctuary. The monarchs were all along the south edge of eucalyptus trees facing the private properties. Even during the
Yeah.
storms, they didn't move into the interior. Why do
Well,
you
they
think?
they scattered after the Christmas storm. Remember? So first, I really want to give credit to the Pacific Grove Museum because they're the ones who do the weekly monitoring. So yeah, they were along the south edge of the grove, but then we had a really major windstorm on Christmas Day And that really scattered the monarchs, and people were, well, where did they all go? And, they were just all over the place. And then when they reaggregated, the conditions on the south edge were good. And we had a very, very mild, warm January. So there wasn't really any reason for them to abandon the south edge. So, it's always a sequence of events that the monarchs have to be able to fly after a big windstorm, for example, because they hang on for dear life, but then uh, if it's cloudy and rainy, they just can't fly. So then conditions get good again. So maybe they decide, maybe I don't want to fly. It's it's as I say, it's complicated.
Definitely engineering happening, definitely biology happening, all rolled up into one.
Yeah, and then there's definitely insect behavior, collective insect behavior that we don't completely understand.
Right. Well, and this was kind of a follow-up question to Natalie's question, and this person was saying, I wonder if it had anything to do with the residential pesticide application that had occurred on the east side of the sanctuary the
Oh,
year before.
yeah.
Is there
Yeah,
memory there?
that was a couple of years ago.
Okay.
And yeah, there was a kind of mass mortality event. A few hundred monarchs were found dead with a whole series of pesticides in them. And obviously somebody had applied some insecticide that got to them and that they were exposed. But there have been a lot of education, and we haven't seen a repeat of that in in recent years.
Good to know.
But yeah, that was a tragic, really good example of what happens when you're in the middle of an urban area and people aren't thinking about their pest control.
Mhm. Um, the couple of questions kind of all over the place, but trying to hone in here. Do you know if there's any management happening in the Ventura overwintering site?
Uh, with Althouse and Mead, we did a series of site management plans, one at Camino Real Park, and then another one at Harbor Boulevard. So we did assessments, came up with some tree planting and management suggestions for those two sites. We also in Oxnard, there's I'm trying to remember the name of it. It's like a cemetery. We planted some additional trees there after we did an assessment. And then over a really interesting site, it is a riparian site just east of Ventura. It's largely a sycamore forest, and there's a few eucalyptus, but we were able to get paired hemiphotos of leaf-on sycamores, which actually made pretty good habitat, but they lose their leaves. They're deciduous, so that by January, they've lost their leaves and the forest just became way, way too open. So that's kind of an example of a transient site in a canyon in Southern California, where they'd show up in the fall, but then the trees would lose their leaves and it just became too open for them. Um, so yeah, I know there's some quite the controversy at a development site in Ventura, and we're sort of waiting for the word to like do an assessment and come up with a site plan and see if we can reconcile development potential with keeping it as a monarch site. But a lot of trees were cut quite recently.
Okay. I really like this question a little more on the engineering side of things. Is it possible to create man-made trees like cell phone towers to help with windbreaks? Not necessarily, to compensate for trees for roosting, but some sort of idea
Yeah.
of additional windbreak.
Okay, so back in the early 1990s, there's a site, like I say, I've seen it all, so that's a great question. There was a site at Ardenwood Regional Park in the East Bay, in uh, yeah, in the East Bay, San Francisco area. Um, the forest just got hammered by the first wave of longhorn borers and lerpsilids. So it really, really thinned out and was in really bad shape. So at East Bay Parks brought in some stadium wind screens and put them up, and it actually seemed to work for a couple of years around this one site. They're really hard to maintain because the attachments to the trees weren't really that solid, and it's potentially a pretty good short-term solution if everything is lined up correctly. Uh, Buildings, that's a man-made structure. As long as the building isn't blocking the light, then it could actually be a really good windscreen. And because some of these Monarch sites are so packed in to heavily urbanized areas, it's might be there might be some, opportunities there like there were at the Gill tracts.
Interesting. Love that. I'm just going to ask one more question and then we're going to be at time here. Do they have any guidelines? And I know that different sites, are managed very differently. Are there different guidelines for mowing at overwintering sites or kind of for that underbrush upkeep and such?
Oh, I think that's something that's like under development. You do want to have some vertical structure on the forest floor so that monarchs that get knocked down aren't have a place to crawl up on, because every inch they get up above the forest floor, it's the temperature gradient there is extreme. So they'll be able to fly away and recover a lot sooner if they can be up a few inches. The issue of like fuel continuity is maybe more important, that you can still have stuff on the forest floor, but it can't be like a continuous fuel load so that the fire would carry. Then also you don't want to, any mowing or forest floor manipulation needs to be done outside of monarch season.
Great. Well, there are a few more questions, but we'll send them to Stu. We'll get them answered. I know there was a few questions that were more related to milkweed and planting, so we'll definitely include some Monarch joint
Okay.
venture and Xerces resources in the email. But we're super grateful for your time today and your expertise. Thank you all for participating and for your questions. We would love for everyone to fill out the feedback form. Alyssa is going to drop that into the chat. If you could just click on that and open that into your browser and fill that out real quick once we're done, we would really appreciate that. We really hope to see you at our next webinar, which will be Tuesday, March 24th. A journey through the monarch's winter home, the sights, sound, and science of migratory monarch butterfly colonies. We'll be joined by Court Wieland, expedition leader, MJV board member, and chief sustainability officer at Natural Habitat Adventures. Thank you so much, everyone. Have a great day.
Thank you.